Hello guys, how are you today? So today I'll be explaining the CQD questions from chapter 2, which is 2.19 until 2.23. I will do chapter 2 by itself and chapter 3 by itself. So they told us, when an electric immersion heater is connected to the 110 volts, this is our voltage or potential difference, main supply, a current of 50 amperes, this is our current I, flows through it. The water tank contains 100 kg of cold water, this is the mass, and remember in physics the mass is always in kg, at 30 degrees Celsius, which is what? This is the temperature in degrees Celsius. They told us to calculate the temperature of the water after 1 hour. This is our time. Assume the tank itself has no heat capacity and is perfectly lagged, so keep these in mind. The specific heat capacity of water is 4.2 times 10 to the power of 3 joules per degree Celsius times kg. So what we need to know is that there is something in common, okay? So let us first write what we have. We have what? We have the voltage or potential difference. We have the current I. We have the time T, but we need to change it to seconds, of course. Then we have the mass and we have the temperature in degrees Celsius. Okay, now if you remember, we know that what? The energy Q or E is equal to what? M times C times delta T. But we also know that Q, the energy, is equal to what? It is equal to I times V times the time T in seconds. So we have our current I, which is 50 amperes, times our voltage V, which is 110 volts, times the time in seconds. So 1 hour is actually 60 minutes. So 1 hour is 60 minutes. Of course, we have to change this to seconds by multiplying by 60 to get 3,600 seconds. So this is the first value of Q. If you put it on the calculator, it's gonna be 50 times 110 times 3,600 or 3,600. And we will get an answer of 19,800,000. Okay, so we know this is the value of Q. We also know that Q is equal to what? To the mass, which is in kg, which is 100 kg, times the C of water, which is 4.2 times 10 to the power of 3, times what? Times the change in temperature. Now, the change in temperature, we do not know which is the initial temperature and which is the final temperature. Okay, but actually, if you go back, you are given what? You are given the temperature in degrees Celsius. So we will label this as temperature initial. Okay, and we know that delta T is what? Delta T is temperature final minus temperature initial. So we can find the value of temperature final since we have the value of temperature initial, which is 30 degrees. Okay, but 30 degrees Celsius. And we also know that Q is what? Q is 19,800,000. So if we put it all as an equation, we get that temperature final minus 30 degrees Celsius is equal to 19,800,000 divided by 100 times 4.2 times 10 to the power of 3. So if you do it on the calculator, okay, you are gonna get an answer of approximately 47. So temperature final minus 30 degrees Celsius is equal to approximately 47 degrees Celsius. So that means what? That means temperature final is equal to 44 degrees Celsius plus 30 degrees Celsius. Sorry, this is 47. Okay, so 47 plus 30, which will give us an answer of 77 degrees Celsius. So for part 50 or number 50, the answer is gonna be 77 degrees Celsius. So we are given what? We are given a resistor of resistance 15 ohm and a volt, or it has a voltage or potential difference of 24 volts. They need the power dissipated by the resistor. We know power is equal to what? It is equal to the current times the voltage. So how can we find the current if we are given the voltage and resistance? We know that the current I is equal to the voltage divided by the resistance. So voltage is 24 divided by the resistance 15. Put it on the calculator. You will get an answer of 1.6. So we are given the current to be 1.6 Okay, so we are gonna do 1.6 times the voltage, which is 24. So if you do it on the calculator, you will get an answer of 38.4. So you could do it like this. Okay, this is the first way to do it. Or you could memorize that the power is equal to the voltage squared divided by resistance. So voltage is 24. So then it becomes 24 squared divided by the resistance, which is 15, and we will get the same answer, which is 38.4. Okay, so that is 51 grid finished. Moving on to 52 grid. A 25 resistance resistor, this is a resistance, is connected to a 10 voltage power supply, voltage or potential difference. They need the energy dissipated by the resistor as heat in 30 minutes, so we have the time. First thing, we need to know the equation. Energy dissipated means Q. Q is equal to I times V times the temperature. Sorry, not the temperature, the time, my apologies, the time. So how can we find I? We know that I is equal to voltage divided by the resistance. So the voltage is 10 divided by the resistance, which is 25. If you do it on the calculator, you are going to get an answer of 0.4. So we have our current, which is now 0.4, so I is equal to 0.4. We have our voltage, which is 10 volts, okay. All we need is our time in seconds. So it's going to be 30 minutes times 60 seconds, so 1,800 seconds. So then, if we put them all together, it's 0.4 times 10 times 1,800, which gives us an answer of 7,200 joules. Now pay attention if they want it in joules or kilojoules. If they want it in joules, you keep it like this. If they want it in kilojoules, you divide by 10 to the power of 3. So we finished 2.19, we move on to 2.20. So here they asked us, what is the difference between a rheostat and a potentiometer? First thing, we know that both a rheostat and potentiometer are variable resistors. Okay, now the main difference between the rheostat and potentiometer is that potentiometers are used to vary the voltage or change the voltage, okay? Whereas the rheostat is used to change the, so the rheostat is used to change the current. Another main difference between the two is that the rheostat has 2 terminals, okay? That means, in some sense, it is connected in series, just like the ammeter, whereas the potentiometer has 3 terminals. That means it is connected in parallel, just like the voltmeter. So that's pretty much it for question 53. Okay, so we move on to question number 54 grid. A potentiometer is connected parallel to a voltage source as shown in the diagram below. The schematic diagram of potentiometer is also shown. An IGCSE student needs an output voltage of 3 volts or a voltage of 3V for an electric motor that she constructed. Where should she place the wiper of the potentiometer? Explain your reasoning. So over here is the wiper and this is the potentiometer, not the potentiometer, this is the potentiometer. But this wiper, as you move it, you can change what? You can change the extent of the voltage that passes through it. So you can change the voltage. Okay, so as you can see, we have that the total voltage emitted by the battery, let's say there's a battery over here, the total voltage is 6 volts. So if she needs 3 volts, then she needs approximately half of this. So she needs like literally half of the voltage. So what you're gonna do is you're gonna take a ruler, you're gonna measure it, let's say it's like 10 centimeter, and you're gonna put it exactly halfway, which is 5 centimeter. You're gonna put the wiper exactly halfway. So it will be positioned exactly in the middle, okay, so that she will get a voltage of 3 volts. Moving on to section 2.21. Okay, they told us, draw a labeled circuit diagram showing all the apparatus necessary in order to find the characteristic of a filament lamp. So I'm gonna draw it as how they explained it. So over here we have a circuit. Then we have battery 1, battery 2. Then over here we have a potentiometer. Okay. Then we have here a an ammeter to measure the current. Here we have the bulb, and here we have the voltmeter to measure the voltage. Actually, here's the ammeter. I think this is a resistor then. So this is what the graph looks like. Let me just, draw this a bit up so it's a bit clearer. So this over here is what the graph looks like. So they need us to what? They need us to find the characteristics of a filament lamp. So to find the characteristics of a filament lamp, first of all, you need to be able to control the voltage, okay? Or in some other sense, to control the voltage being emitted from the positive side, okay? Until it comes here and whatever. Actually, it will come like this, and then until it reaches the negative side. So they will control if you want 3 volts, 5 volts, 10 volts. Let's say the total is 20 volts. This, you control how much you want. Then they have another resistor over here. This is a stable resistor, okay? Then over here, this is the voltmeter to measure the voltage that passes through the filament lamp, and then the current. Okay, so what they could do possibly is to see if you decrease the voltage, what happens? If you increase the voltage, what will happen? So they told us in part B, what happens with the resistance of the filament lamp as the current increases? So very simply, what happens with the resistance? So how much can the lamp resist? If you increase the current, definitely how much it can resist will increase with an increase of the current, because you're technically letting more of the current to be resisted. Now they asked us in part 2, is the filament lamp an ohmic conductor? Okay, we know an ohmic conductor's IV graph is a straight line passing through the origin, okay? However, we know that the filament lamp's IV graph looks something like this. Or actually, no, it's like this. Forgot how to draw it, sorry. Okay, so the IV graph of a filament lamp looks like this. So definitely it's not an ohmic conductor since it's not a straight line passing through the origin. That's pretty much it for question number 25. Question number 55. Question number 56 grid. Consider the circuit diagram below. What is the component X called? This is called a diode. Okay, so you have to remember what this is and what it looks like. They said, what happens to the circuit when the poles of the component X are flipped? Now, look how I think of this, okay? If you get confused about this in the exam, you know that the circuit flows from where? From the positive side all the way to the negative side. So if you're gonna flip the diode, and let's say you put it like this, okay? The current, which is going like this, is gonna be blocked from here. So it's not gonna be able to pass. Okay, so very simply, if you flip it, then the current will stop flowing in the circuit. Moving on to question number 57. Describe and draw the IV characteristics of the following graphs. You just need to draw the graphs. We know that in an ohmic conductor, its graph is a straight line. We're talking about an IV graph. Is a straight line passing through the origin. Okay? Then if we have a filament lamp, its IV graph looks something like this. Okay, I'm not the best at drawing, but it looks something like this. Okay, then if we have a thermistor, its IV graph looks something like this. Okay, and then finally, if you have a semiconducting diode, its IV graph looks something like this. Okay, this is all you need to know. You do not need to describe, you just need to know how to draw them. So moving on to section number 22, simple circuit, series and parallel resistors. So the resistors of resistance 2 ohm, so we have resistance 1, then resistance 2 is 4 ohm, are connected in series across a battery of composed 1.5 voltage dry cells. So over here, this is our potential difference or voltage. An ammeter in the circuit shows a current of 0.5 amperes, so this is our current. They said, what is the total potential difference applied across the circuit by the battery? So very simply, how we are going to find it is we are going to find the equivalent resistance, okay? To find the equivalent resistance, since they are in series, we're just going to add them. So 2 plus 4 equals to 6. So 6 is our resistance. We are going to multiply it by our current, which is 0.5, since the current is the same everywhere in series. So 6 times 0.5 is what? Is 3 volts, 3 voltage battery. So now, what are the possible arrangement of cells in the battery? So here, what they wrote in the answers is a bit confusing. So I will just draw the possible arrangement of these cells. So you could have it like this, they're saying. Okay, you will have two 1.5 volt batteries. Okay, and if they are more than 2, you just put them in parallel. They will like give you always the same result. Okay. Or they said you can take one and put it always, like for example, let me just clear the page. You take one and you put it in parallel with another one, for example. And then you put it in series with what? With another one which has the same thing. And then you are going to get literally the same exact thing. And then the last one is a parallel combination of both of them. So it will just result in just being more of this. Whatever this is, I have no clue, but it's okay. So all you need to know, they said, is a series of parallel of series and parallel of the first two, whatever it is. So we move on to question number 59. A 1.5 voltage dry cell is connected to a small light bulb with a resistance of 3.5 ohms. This is our resistance. How much current flows through the bulb? Very simply, we know that the current is equal to the voltage divided by the resistance. So it is the voltage of 1.5 divided by the resistance of 3.5, which gives us an answer of, let me just put it on my calculator. It will give us an answer of approximately 0.43. This is our current. Okay? Then they told us a current of 6.25 amperes flows through a microwave oven. They told us if the resistance of the circuit is 17.6, what is the voltage across the oven? Very simply, we know again that the voltage is equal to the resistance times the current I. So the voltage, we need to find it. It is resistance, which is 17.6 times the current, which is 6.25. If you put it on your calculator, you will get an answer of 110 volts. So that is it for question number 59. Moving on to question number 60. What's the equivalent resistance of the following resistors? Since they are in series, you just add them. So 15 plus 25 plus 50, you will get an answer of 90. Sorry for the bad handwriting. 90 Okay, so moving on to the next one. What's the equivalent resistance of these resistors? Since they are all in parallel, we are going to take 1 over 10 plus 1 over 15 plus 1 over 20. Here we cannot apply the product over sum rule because they are more than 2. So if they are 2 and only 2, then we can apply the product over sum. Otherwise, you need to apply this rule, which is 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus etc. Okay, so if you add them all together, you are then gonna get 1 over 10 plus 1 over 15 plus 1 over 20. You will get an answer of 13 over 60, but this is not what we are looking for. We need to flip it. So then it becomes 60 over 13, which is approximately 4.6 ohms. So this is the equivalent resistance. We move on to question number 62. Okay, 3 resistors of resistance 1, 2 ohm, resistance 2, 4 ohm, and resistance 3, 9 ohm are grouped as shown in the figure below and fed by a generator of electromotive force 4.50 volts. They need us to calculate the voltages across R1 and R2. So very simply, how we are going to do that is, since we are dealing with series in parallel, okay, we will first add the series together. So R1 plus R2 to generate the R equivalent, which is going to be then 6 ohm. And since they are in parallel, we can apply, and since they are only 2, by the way, we can apply the product, which is 6 times R3, which is 9, over the sum rule. So 6 times 9 over 6 plus 9. If you do it on the calculator, you are going to get an answer of 3.6. So this is the total equivalent resistance. So all in total, it has an equivalent resistance of 3.6 ohm. Okay, so now they need the voltages across R1 and R2. What we can do is we can find the current. So we have resistance, we have voltage, we can find the current. So I is equal to V over R. I is equal to 4.5 over 3.6, which is 1.25. Okay, and now since we have the current, we can multiply it too. We can divide the current by each of the resistances. But here there is a slight problem, is that the current will separate here and here. It will split because in parallel the current split, whereas the voltage stays the same in parallel. So to find the voltages across R1 and R2, very simply, we first need to find the current that went through R3, okay? To do that, we are going to take the total voltage, which is 4.5, and divide it by the resistance in R3, which is 9. You will get an answer of 0.5. Now what we are going to do is we're going to take the original current, which is 1.25, and subtract from it 0.5. This gives an answer of 0.75. So now we know that the current coming here is 0.75 amperes. Okay, now to find the voltage across R1 and R2, very simply we're going to take the current 0.75 and multiply it by the resistance of each. So for R1 you are going to get an answer of 1.5, and for R2 you are going to get an answer of 3 volts. Now, if you want to see something nice, we know that in series, the voltage is gonna be separated or split. So if you add these two, since they are in series, by the way, you add them together, 3 plus 1.5, you are gonna get 4.5. So that is it for question 62. We move on to section 2.23. Okay, so question 63 grid. A 500 ohm to 1 milliampere ammeter is to be made into an ammeter that can read up to 5 amperes. Determine the shunt resistance needed for that purpose. We are dealing first of all with the ammeter and shunt resistance of the ammeter. What we should know is that the ammeter is connected in series, so the shunt is going to be connected oppositely, so in parallel. Okay, and then we need to apply this equation. The equation very simply states that the resistance of the current, I, okay, multiplied by the current initial, or the initial current, is equal to the resistance of the shunt multiplied by the needed current, which is the, for example, in this case, it is the current that we need to read up to, minus the original current. Okay, if we apply this, we have that the resistance of the current is 500 ohm multiplied by the initial resistance, which is 10 to the power of minus 3. Okay? If you don't know how I got it, it's 1 milliampere, so 1 times 10 to the minus 3 is equal to the shunt resistance that we need to find times the needed, or the one we need to find, which is 5 minus 10 to the power of minus 3, because this is original current. So if you bring this to the other side, you are going to get 500 times 10 to the power of minus 3 divided by 5 minus 10 to the power of minus 3. And you are going to get an answer of 0.100200004, whatever. So approximately 0.1 ohm. So this is our shunt resistance. And you should know that it's always supposed to be a small number, like a really, really small number. Because shunt resistance has to have a small resistance. Okay, so we move on to question number 64. An electric loader used to lift weight operates at DC voltage 24 volts and current 3.2 amperes. They need the power drawn by the loader. Very simply, we know that power is equal to the current I times the voltage V. So it's very simply 3.2 times 24, which is 77 watts. Okay, this is part A. Now, I don't think we're responsible for efficiency, but there's no harm in doing these questions. So, the efficiency of the loader is 80%. Determine the power output of the loader. Very simply, to find the power output of the loader, it is what? It is the power out divided by the power in times 100%. okay, is equal to efficiency. This is the equation we are going to be using. We've never taken it before. I saw it on the answers, so let me explain how we are going to use it. The power out over the power in times 100% is equal to the efficiency. We have our efficiency. We have the power in, which was 77 watts. Okay, all we need to find is the power out. So to make the power out as the focus of the equation, this is going to be power in times the efficiency divided by 100%. So we have the power in, which is what? 77 times the efficiency, which is 80%. If you cannot write the percentage on your calculator, you can write it as 80 over 100. So 77 times 80 over 100, all of it over what? Over 100%. So 100 over 100. Okay. And you are going to get an answer of 61.6 watts. So the power output is 61.6 watts. Now give two reasons why the efficiency of the loader is less than 100%. First reason is friction, okay? And second reason is that heat could be dissipated. Alright, moving on to part C, they said determine the time it takes to raise a weight of 1000 Newton by 1.8 meters using this loader. So they need the time, okay? We know that actually the energy E or Q, however you denote it, is equal to the power times time, okay? So let us first of all find the power. So looking for the power, it's usually the power output, which in this case is 61.6. So this is 61.6 times the time, which is the focus that we need to find, is equal to Q, which is the energy, or as some of you denoted by W, which is the work. So to find the work, okay, we need to do mgh. So W is equal to mgh because we are dealing with height and whatever. So we are already given the weight, and we know that the weight is equal to m times g. So remove these. We have the weight 1000 newtons times the height, which is 1.8 meters. So you are gonna get the work or the energy to be 1800. So now to find the value of t, you are gonna take 1800 divided by 61.6, and you are gonna get an approximate answer of 29, and always the time is in seconds, so 29 seconds. Moving on to top question number 65. They need us to determine the equivalent resistance of the circuit. So we have here our first resistance, so this is R1, this is our second resistance R2, and our third resistance R3. Okay, so as you can see, this resistor is in series, whereas these two are in parallel. So what we are gonna do is first we are gonna find the equivalent resistance of these two. We can apply this the product over sum. So 20 times 20 divided by 20 plus 20. We are gonna get an answer of 10. And since now they are in series, we can just add them together. So it's gonna be 10 plus 40, which is then 50. So the equivalent resistance of the circuit is 50 ohm. Now they said determine the current. Part B. Determine the current through point D. Very simply, to find the current through a point, we have the total voltage, which is 3, and we divide it by the equivalent resistance, which we found over here to be 50 ohm, and we will get an answer of 6 times 10 to the power of minus 2 ampere, or 60 milliampere. Okay, now to find the value through point A, we have many ways to do this, but very simply, what we are gonna do is we are gonna take this current, okay, we're gonna multiply it by the equivalent resistance of these two, which is 10 ohm. Okay, we get 600 milliampere. Then we are gonna take, it's not milliampere, it's 600 volts, or 600 millivolts, whatever this is, okay? So we are gonna take this voltage, 600 millivolts, and divide it by the resistance, which is 20 ohm. And we will get an answer of 30 milliamperes. milliampere. Now, this is over here, it was 60 milliampere, here it was 30 milliampere, and through point C, since they are identical, we can directly say that the current is the same through it. Alright, so that is it for part B. Part C, determine the potential difference between A and B and D and E. So very simply, to calculate the potential difference between A and B, we are going to take the total current, which we found, by doing 3 volts divided by the total resistance, which is 50 ohm, to get 60 milliampere of current. Okay, and what we are going to do is we are going to take this, multiply it by the equivalent resistance here, which is 10 ohm, to get 600 millivolts or 0.6 volts. So for part A, the potential difference is 0.6 volts. Now between D and E, it's gonna be this current, which is 60 milliamperes times 40. So it is gonna be 60 times 40. So it's gonna be 2,400 volts, but sorry, not volts, millivolts, but then to change it to volts, it's gonna be 2.4 volts. That's it for question number 65. We move on to question number 66. They told us a metal sphere is positively charged and placed on an insulating stand as shown below. An initially neutral metal ball hanging from a thread is brought near the sphere. Describe any changes in the charge distribution in the metal ball as it is brought near to the sphere. So the electrons of the ball will move closer to the sphere, okay? Or the side that has the more electrons will move closer to the sphere because it is positively charged. The ball is now very close to the sphere. Describe its subsequent motion. It's gonna touch the sphere. So when it touches the sphere, it's gonna give some of the electrons, and then it will both become neutral, so it will go back. We need to provide why. Now, the first way was just my way of explaining it. So what actually happens is when the ball comes really close, the negative side is gonna come over here. So they're gonna touch each other at some point, and the electrons from this are gonna come here, and at some point they are both gonna become neutral. So they are gonna lose what? They are gonna lose, this is not neutral, I'll just like write this for neutral. They are both gonna become neutral, so there's gonna be no force of attraction, so it's gonna come back here. But at the same time, this is still positively charged, so it's gonna be taking a lot of electrons, which will leave this to be positively charged, and this is still positively charged because it's a really big positive charge, which will cause two positive charges, or both of them having the same sign, so they are gonna repel. So that is it for chapter 2. Thank you guys for watching. I hope you enjoyed and have a wonderful day.